Hello students, the next topic is aldehydes and ketones. Now, these two are separate classes of organic compounds. We will know the details of aldehydes and ketones together in the introduction, and then I will split the nomenclature, methods of preparation and properties of aldehydes, and then take up ketones. So let us know what are these aldehydes and ketones. Aldehydes and ketones are two classes of organic compounds which contain a common carbonyl group. C double bond O group is called as the carbonyl group. Yes. Now, in case of aldehydes, the carbonyl group is present in the terminal position, that is at the end of the chain, whereas in case of ketones, the carbonyl group is present in between in the chain, that is in a non-terminal position. The difference between the two is due to the other substituents which are attached to the carbon atom of the carbonyl group. The general formula of aldehydes is given as RCHO. So RCHO is the general formula of aldehydes. Now here R can be either hydrogen or alkyl group or aryl group. Coming to the general formula of ketones, it is RC double bond O R dash, where R and R dash are either alkyl or aryl groups. R and R dash will never be hydrogen. I hope so. If you have understood, if any one of them is hydrogen, then it will be an aldehyde. It will no more be a ketone. So this is regarding the definition of aldehydes and ketones. Now let us continue with the nomenclature of aldehydes. In particular, nomenclature of aliphatic aldehydes. In case of aliphatic aldehydes, in the general formula RCHO, R will be either hydrogen or alkyl group. So R is either hydrogen or alkyl group, and the general IUPAC name is given as alkanal for aliphatic aldehydes. Now this name alkanal is obtained by replacing E of corresponding alkane ending word E by the alphabets AL. Remember that you will select the parent chain such that it is the longest continuous chain which contains the carbonyl carbon, and that carbonyl carbon gets the lowest possible number. So this is for the nomenclature of aliphatic aldehydes. Now let us look into a few examples of aliphatic aldehydes. So as you all know, there are two systems of naming, the common name and the IUPAC name. The first member is obtained by replacing R by hydrogen in the general formula RCHO. That is, it becomes HCHO. The common name given to it is formaldehyde, whereas the IUPAC name alkanal, which is the alkane containing one carbon, methane. So E should be replaced by Al. Therefore, the IUPAC name will be methanal. E is replaced by Al. So therefore, the IUPAC name will be methanal for formaldehyde. Now the next member, add a methylene group, CH2 group, it is CH3CHO. CH3CHO has the common name acetaldehyde. So CH3CHO has the common name acetaldehyde. Coming to the IUPAC name, there are two carbon atoms as numbered there, 1 and 2, right? So the alkane having two carbon atoms is ethane. Replace E by Al, you will get the IUPAC name as ethanal. Al is the ending. Now another example, Yes, increase one more methylene group CH2, it is CH3CH2CHO. The common name is propionaldehyde. It is called as propionaldehyde. Now coming to the IUPAC name, there are 3 carbon atoms. The alkane having 3 carbon atoms is propane. Hence E is replaced by Al. Its IUPAC name is propanal. Next example. Another methylene group is added, 4 carbon atoms as numbered there. So the common name is N-butyraldehyde. It is a straight chain compound with the same molecular formula. Another structure is possible. So the prefix used here is N. If you look there, N-butyraldehyde has 4 carbon atoms. So the alkane with 4 carbon atoms in a straight chain is butane. Hence the IUPAC name will be butanal simply, or even you can indicate the locant to 1. It is not necessary. One can be either indicated or it can be ignored. Butanal will be the IUPAC name. Look to the next example there. Formula is the same but structure is different. There is isopropyl group. I hope you remember isopropyl group, that is CH3CH3. That group is called as isopropyl group. Now here this is called as isobutyraldehyde in the common system. Whereas coming to the IUPAC name of isobutyraldehyde, the parent chain has 3 carbon atoms and to the second carbon atom there is a methyl group. So the IUPAC name will be 2-methyl-propanal. Just look here, it is 2-methyl-propanal. So these are a few examples of aliphatic aldehydes, the common names and IUPAC names. Now let us move to the nomenclature of aromatic aldehydes. As I have told earlier also, aromatic aldehydes have popular common names which are accepted by IUPAC. Now in case of aromatic aldehydes, in the general formula RCHO, R is an aryl group or aromatic ring. So the CHO group is usually directly bonded to the aromatic ring. The simplest member as indicated here is C6H5CHO. So aldehyde group is directly bonded to the aromatic ring. It is called as benzaldehyde. Yes, it is called as benzaldehyde, or another name for it is benzene carbaldehyde. That is also correct. Benzaldehyde or benzene carbaldehyde. Now in case of disubstituted derivatives, the prefixes ortho, meta and para is used, and if the groups are different then you can use the numbers. Just look to the next example there. Now this is called as ortho-nitrobenzaldehyde or 2-nitrobenzaldehyde. Another example. Yes, nitro group is at the para position. Para-nitrobenzaldehyde, or it can also be called as 4-nitrobenzaldehyde. This is in detail regarding the nomenclature of both aliphatic aldehydes as well as aromatic aldehydes. I hope nomenclature is clear to you all. Let us continue with the methods of preparation. Now coming to the methods of preparation of aldehydes. First we'll discuss aldehydes in detail, then we'll go to ketones. The first method of preparation is by oxidation of primary alcohols. The general formula of a primary alcohol is RCH2OH as indicated here. So it is by oxidation of a primary alcohol. So oxidation of primary alcohol can be carried out using acidified potassium dichromate. K2Cr2O7 is potassium dichromate. Even you can use acidified potassium permanganate, that is KMnO4. If you take here acidified potassium dichromate, K2Cr2O7 and H2SO4 react to liberate nascent oxygen. So the oxygen indicated in square bracket is liberated by the reaction between K2Cr2O7 and H2SO4. Elimination, just look there in the structure of primary alcohol, the arrow is shifting from CH bond towards CO bond, so that a carbonyl group is obtained. H2O is eliminated as the byproduct water, so that you will get the product as RCH double bond O, that is nothing but an aldehyde, RCHO plus H2O. So this is the oxidation of primary alcohols. To take one particular example, ethanol CH3CH2OH on oxidation using acidified potassium dichromate K2Cr2O7 H2SO4 will give you ethanol plus H2O. Another example, C6H5CH2OH is an aromatic alcohol. C6H5CH2 group is called as benzyl group, hence it is benzyl alcohol. Benzyl alcohol on oxidation with acidified potassium dichromate, once again H2 and O is eliminated as water, and you will get CHO group attached to the aromatic ring. The product obtained is benzaldehyde C6H5CHO plus H2O. Now, the next method of preparation is by catalytic dehydrogenation of primary alcohols. What is dehydrogenation? You should know the meaning of the term dehydrogenation, that is elimination of hydrogen. Catalytic dehydrogenation indicates the hydrogenation is carried out by using a catalyst. Now coming to the general reaction. For carrying out this dehydrogenation, we consider volatile vapors of a primary alcohol. So alcohols are liquids. If you heat them beyond their boiling point, you will get the volatile vapors. So if you pass the vapors of primary alcohols over copper catalyst at 573 Kelvin. So I have showed the elimination of H plus and H minus as H2. You will get the product as RCHO, which is nothing but an aldehyde with the elimination of H2. So this is dehydrogenation reaction. The catalyst used is copper catalyst and the temperature maintained is 573 Kelvin. Now to take one particular example. Yes, if you take the volatile vapors of ethanol CH3CH2OH and passed over heated copper catalyst at a temperature of around 573 Kelvin. The product obtained is CH3CHO, that is ethanol plus H2 hydrogen. So you can also take the vapors of benzyl alcohol and carry out the reaction. The next method of preparation is a named reaction called as Rosenmund's reduction. So the details of the Rosenmund's reduction and other methods of preparation I will continue in the next class. Hope so. These two methods of preparation, that is by oxidation of primary alcohols and catalytic dehydrogenation of primary alcohols, is clear to you all. So students, I will stop the class here and continue in the further class. Thank you.